Hi class, this is Jeannie Moran, and this week for advanced concept number 4, we are going to make some elephant toothpaste using some concepts that we're studying this week in chemistry too, which are also some concepts which overlap in biology, and even if you go further into biochemistry. But what we're doing today is just a simple chemical reaction example showing how catalase is used to help lower the activation of energy during a chemical reaction by interacting with chemicals or particular reactions. Okay, so I just want to take a minute first to go over and explain what enzymes do and how they work, and the best way to do that is with a visual. As you can see on the left, the picture looks like a slice of cheese with some cutouts. That's an enzyme. And in our project, the enzyme is going to be the yeast, which is the catalyst. And it is representative in when I'm talking right now, I'm just using catalase as an example because it's a very important enzyme in our human body that breaks down hydrogen peroxide, which is what we're also doing today in our elephant experiment. And how that works is every enzyme has, like, they call them lock and keys. They're basic lock and key method because they have little cutouts that look like a little bite out of the cheese, or maybe a little V-shaped notches where only certain other substrates or molecules can fit in to those sites. So once they bind into those sites like a lock and key into only specific molecules which do so, then the reaction takes place. And after reacting with the enzyme, the products of whatever that reaction might be break free, and the enzyme is ready to start that reaction all over again. And in our experiment today, the yeast is going to react with the hydrogen peroxide, and then the reaction products are going to be H2O water and oxygen, O2. So what we're going to use for today's experiment is an empty plastic water bottle, 1 packet of dry yeast, about 3 tablespoons of warm water to mix with that yeast, a squirt of liquid dish soap. I used Dawn, but I imagine any soap will do because that's just to help create that foam. 3% hydrogen peroxide, about a half a cup, measuring cup, of course, and measuring spoons to measure, and safety glasses. I used my kitchen sink to do my experiment, but you would want to do it anywhere where you don't mind having a little spillage. Our ingredients are pretty safe if you have a stone countertop, but some of the other elephant experiments using different chemicals are a lot more harsh, so you will definitely want to be careful. So let's talk about hydrogen peroxide. So hydrogen peroxide, that goes by the formula of H2O2, is a reactive molecule which will decompose into water and oxygen, and the formula for that is shown below, 2H2O2 to 2H2O plus O2. So here we are going to start by using a measuring cup, and I'm going to add half a cup of fresh hydrogen peroxide, measure that out, and I'm going to come over and pour that through my little funnel into my water bottle over the sink. Just get that in there. It's important to use new peroxide just to make sure that you'll get the full effect of the reaction. Then I take a package of yeast that you buy at the grocery store, and over here I've pre-measured some warm water, and I'm going to be using about 3 tablespoons, since I'm using half tablespoon measuring cup, then I just used 6 tablespoons, and I'm going to try to mix that up pretty good. Seems like it's taking kind of long because it's kind of mushy and pasty, which is the consistency that you want it to be. So actually it's kind of hard to get the stuff on the bottom. So I'm just going to keep mixing that a little bit. And actually it's a good thing to let your yeast sit in the warm water for a few minutes if you can, because it just helps activate those yeast cells. I know from making bread, and I'm sure most of you who've done some baking know that yeast plays a pretty important role. So there I go. So now I'm going to come over and get ready. Well, actually first backtrack. I'm going to add a squirt of dish soap to my peroxide mix. And I'll explain to you what happens, what the soap is going to be used for. And I'm using some food coloring, again, as in other experiments. I just have this leftover gel to use, so that is what I'm going to be using. So in this demonstration, the yeast is going to act as a catalyst, which again is used to speed up a reaction. The yeast is going to catalyze the decomposition of the peroxide so it proceeds much more rapidly than normal. Sorry about the train in the background, guys. I live downtown. So what's happening here is the yeast quickly broke apart the oxygen from the hydrogen and created a gas which wanted to escape, and it would have escaped more in a gas form, but because I added that dish soap, the dish soap traps that gas and makes it into a foamy reaction right there. So you see the O2 and the water, which normally would happen very slowly, but we made it happen a bit quicker by adding the catalyst, which was our yeast. And when I touched the bottle, another thing I noticed that was the sign of a chemical reaction is that the temperature of the bottle is warm. And it's okay for me to touch this because our ingredients were safe. But if our ingredients weren't safe, then we would have had to be worried and make sure we were wearing gloves. Let's see, what else did I want to mention? Well, adding the dish soap, I want to mention the term surface tension because allowing the bubbles to be trapped and creating a lot of foam is an example of surface tension. And what that did was it created a giant looking squeeze of toothpaste looking substance, which was okay. So one last review of our elephant toothpaste experiment. Hydrogen peroxide has been broken down into oxygen molecules and water molecules using yeast, which is an organism containing catalase. And catalase is an enzyme which helps speed up this reaction. The yeast speeds up this decomposition reaction, but the yeast itself does not ever chemically change. During this decomposition reaction, energy in the form of heat is released, breaking the peroxide down into water and oxygen. And again, the bottle and foam were warm to the touch, which is an illustration of an exothermic reaction. This oxygen released is a gas and desperately wants to escape the liquid. However, the dish soap that we added to the bottle traps these gas bubbles using surface tension, forming foam. This reaction continues until the yeast becomes used up, at which point it becomes a limiting factor. When this happens, the reaction will stop unless additional yeast is added to the solution, in which case it will begin again.